Hello, you're on Papa Spot. I'm George. Welcome to episode 2 on this series on setting up infrastructure foundations with Terraform and AWS. And on this episode, I'll show you how I write infrastructure code in Terraform to set up private subnets on my VPC. This is a follow-through episode, so I suggest watching episode 1, which you can access right here. And once you're done, head back to this episode and I'll show you how I extend my infrastructure code to add resources for my private subnets. And so, if this episode and this channel lines up with your interests, click the subscribe button and join me in this journey of learning by doing. So, let's start coding. I'll be using the same repository that I've already created in the previous episode, which is what I have loaded on my Visual Studio Code. But imagine for a moment that I'm working on this project with other people. Before I start making any changes, I need to make sure that my local copy of the main branch of my repository is updated. And to do this, I need to run git pull. This message here indicates that I have the latest copy of the main branch. Now, instead of making my changes directly into the main branch, I'll create a new branch that I will use to put my changes in. Notice that my terminal is updated with the name of the branch that I just created, which is right here. I also need to make sure that my pre-commit git hook is turned on, so I need to run this command. Now I can start writing my code. I need my private subnet to be able to access the internet, and so I need to create elastic IPs that I'll attach to the NAT Gateway resource. Before I start writing the code for allocating elastic IP addresses for my NAT Gateway, I'd like to talk a little bit about the cost of NAT Gateway resources, as this is an important factor in architecting your infrastructure. AWS charges for the time NAT gateways are running, and they also charge for the amount of data processed by the NAT gateway resource. And then on top of that, they also charge for the amount of data transfer between availability zones that involve the NAT gateway. So depending on your appetite to cost, your need for high availability, and the amount of data movement across availability zones, you can have a single NAT gateway that's used across all your private subnets, or allocate one NAT gateway for each availability zone. I'll consider both scenarios in my code. I already have most of the foundation of my code from the previous episode. I have a local parameter here called AZS, which holds the list of availability zones allocated to me, so I need to look through this list to create multiple elastic IPs for multiple NAT gateways. Then set the tags for this resource. I need to update the name tag to make sure that I have unique name for each resource that I create. This block supports multiple NAT gateways by allocating an elastic IP on each availability zone. But I need to update this code to accommodate for a single NAT gateway scenario. So I'll start with changing this local parameter reference in my for each loop to a new local parameter called NAT_AZS. And then I'll head over to my locals.tf and set that new local parameter. And then above this line, I'll introduce a new local parameter and call it NAT gateway count. And I'll set the value to the availability zone count variable that we introduced from the previous episode. And now I need to update my NAT_AZS local parameter to slice the list of the AZS or availability zones to the value of the NAT gateway count. To this point, I still have maintained the logic for supporting multiple NAT gateways. And in order for me to support single NAT gateway, I need to introduce a new variable called single NAT gateway and use that to determine the NAT gateway count for my local variable. So what I have set here says if single NAT gateway variable is true, then my NAT gateway count is 1. Otherwise, it will be the same value as the availability zone count. So next, I'll head over to my variables.tf and set the definition for the new single NAT gateway variable. I set the default value for this variable to false, which means by default, multi-NAT gateway will be set up. So now I'm going to go ahead and save all my changes and commit them into my local repository. I'm getting the old missing Terraform binary error in here, so I'll go ahead and fix this. And I'll set up my ASDF local tool versions. And then once again, save my changes and commit to my local repository. My pre-commit hook returned an error, so let me go ahead and fix that. and the error is on main.tf, line 57, and all my changes have been committed. The next set of resources that I'll set up is the NAT Gateway resource. NAT Gateway is the resource that will allow resources inside the private subnet to connect to the resources outside the VPC, including the internet. With my code set up for Elastic IP resources, all that I need is to look through each created Elastic IP to set up my NAT gateways. So let me go back to my code. In order for my NAT gateway to enable access to the internet for all resources inside my private subnet, I need to attach each NAT gateway to a public subnet. So this means I need to have a list of public subnet IDs. And so to do this, I need to introduce a new local parameter in my locals.tf that will store all my public subnet IDs. Before we go further, let's talk about what this code does. I loop through each public subnet created inside AWS_subnet.public subnet, and then I extract the ID and store them in a local parameter list called public subnet IDs. So how come I'm doing a loop for this resource? So if I go back to the code where I've set up the public subnets, you will notice that I've done a for each logic in this block, which creates a map of applicable resources. Now, if I go back to my NAT gateway resource block, I can then start using the local variable that I've just created to assign a subnet ID, and then add tags on my resource. And then I'll set the name with the key to make sure that I have unique names for each resource created. I need to ensure that the internet gateway on my public subnet is created before setting up my NAT gateway. So to do this, I need to add depends on property. Now I'll save all my changes and commit it to my local repository. The next resource I need to create is the routing table that I will use for my private subnets. I need to associate this with the VPC resource I created previously. So I need this resource created for each availability zone. So I need a for each loop on the local AZS parameter. And then set the tags property with the name of the resource set with the private string and a running count to make sure that I have a unique name for each resource created. Now that I have routing tables created, I need to create the actual routing rule that will allow outbound access to the internet from the private subnet. I need to create this routing rule for each availability zone. So similar to how I set the routing table and the NAT gateway, I also need to do a for each block on the local AZS parameter. I need to set the route table ID property on this block. So the way I'll pull the applicable route table here is to use the key on the for each loop to access the applicable element in my route tables that I've set up previously. I also need to set some gateway property for this route. And because I'm creating this routing rule for private subnet, I will not be using the internet gateway, but I'll use the NAT gateway instead. And I'll use the same loop key to extract the applicable NAT gateway ID reference. And lastly, because routing rules usually take some time to create, I'll set the timeout to 5 minutes to give the process enough time. Save my changes and commit that to my local repository. My pre-commit hook returned some errors, so let me fix that. It looks like another typing error. Save my changes and try to commit that again. So far, everything returns clean after validation, so let's move to the next resource. Next up is the actual private subnet. So I need to attach this to the VPC resource that I've previously created. So I will use a variable here that will contain a list of CIDR blocks for my private subnets and use each element as the CIDR block property. And then now I need to set the definition for the new variable that I've introduced. I'll set a default value for this new variable into an empty list. I have to set the availability zone property for my private subnet. So I will use the local AZS parameter to fetch the applicable availability zone to use. So I'll go back to my main.tf. And lastly, I'll set the tags property. I'll be setting the name, adding the string private so I know that the subnet is a private subnet, and add a rolling counter to make sure that I have a unique name for each resource. save all my changes, and commit to my local repository. My pre-commit hook has returned errors, so let me go ahead and fix that. Save my changes and commit to local repository. And last but not the least, we create the route table association. So this is the last piece of resources that will put everything together. So I need to attach each route table association to each private subnet. This is route table association, so I need to set the route table ID property for this resource. However, my route table resources are created based off availability zones, but this route table association is based off private subnets. So there's no direct correlation that I can use to set in here. But what I can do though is introduce a local parameter that will store all the route table IDs for my private subnet. So let me head to my locals.tf, and I'll look through all my route tables and store the ID to a local parameter. And now I can go back to my route table association and assign the route table ID property by picking up an element from my local private route table IDs parameter. So let me go to my main.tf. Now save all my changes and then commit it to local repository. So now I'll push my changes to the remote repository. So all my changes are now synced with my remote repository. What I need to do next is to head over to GitHub and create a pull request to merge my changes into the main branch. So let me switch to my browser. Whenever I have unmerged changes, GitHub has some smarts to tell me that I need to create a pull request to merge my changes from a branch that I created with the main string. So I'll click this compare and pull request button right here. This will give me another chance to review my changes. So what I can do is just copy this one. And then if I'm happy, I'll go ahead and click create pull request button right here. If I'm happy with all the changes I've done, I'll come all the way down in here and then change this to squash and merge and click squash and merge, confirm squash and merge. So my changes are now in the main branch. So let's go back to the main page for this repository and review the list of changes. If I open this last commit, it will show me all the changes that I've merged previously. So everything looks good. So now if I go back to my VS Code, and because I'm done with my work and all my changes have been merged to main, I can go ahead and delete this branch on my local. So firstly, I need to switch to main and then delete the branch that I created. That's it for now. On the next episode, I'll put all of this together and show you how I use this Terraform module to create my own VPC in AWS. In the meantime, let me know your thoughts in the comments below and send me some likes if you find this useful. Don't forget to hit that subscribe button if you like what you see and help me spread the word about this channel. Until next time, keep learning and stay safe. See ya.